right, so let's look at convergent plate boundaries. So there are a few types that we're going to be looking at. And so we have our convergent. And what we've looked at so far is we've said divergent is divide, our transforms slip and slide. Well, convergent is collide. So collide, divide, slip and slide. Hopefully to remember them all. And if we are looking here, we have our lithosphere. So these are our plates and they are coming together and one is going to be going underneath the other one. And the reason it's going underneath is because it is denser. And as it's going down, it's going to get into the asthenosphere and it will start to melt and then make its way back onto the surface and we get volcanoes. And so if those volcanoes are on land, we call it a land arc. And if they are in the ocean, we call it an island arc. So the first one we're going to talk about is we have two different types of subduction. And the one we're going to look at first is an island arc. So what happens here is you have two plates coming together and one sinks under the other one. And with island arc, okay, think islands, ocean, it's going to be ocean crust to ocean crust. So which one, because they're both oceanic crust, will sink under? It's the one that is more dense. So what is driving this process? Well, same as before with divergent is we are getting our convection. And looking at that diagram above, so that plate can sink down, remelt in the asthenosphere, and we can get volcanoes. And right here, it's going to be bringing the land down a little bit, and we're going to get something called a trench. So pretty much a hole in the ground. And the best example for this is Japan. Japan is an island arc. So now we're going to look at another type of subduction. And this is a land arc. So it's occurring on land. So it's the same thing. One plate sinks under the other. So this would be our oceanic crust. And this would be our continental crust. And we are going to be making those volcanoes on land. And you're still going to get a trench. And the best example for this, the Andes Mountains. So we can also get, we have subduction, we get something called collision. And sometimes it's referred to as mountain building. And it's with continental crust meeting continental crust. Neither is going to subduct underneath each other. They collide, and what happens is they're going to buckle on each other. So think if you had two like wet graham crackers and pushed them into each other, that they would just build on each other and get higher and higher and higher. So what we're going to get is very, very tall mountains. And the best example here is Mount Everest. And features we get for a convergent boundary. We get volcanoes, mountains, and trenches. Okay? Only convergent boundaries are we going to get trenches, and we get faults and earthquakes. So let's look at our reference table right here, and let's take green for our subduction, our convergent boundaries. Okay. Remember, these are collide. Oh, and I didn't write this here. Slip and slide. Okay, so it's showing these arrows coming together. It tells you which one is the subducting. So subducting means going under, and the overriding plate is the one that stays on top. So subducting, that goes under. So your trench would be on the side of the subducting plate. So let's go through, and we will trace over all of those. And when you're doing this, look at things. So like right there is the Marianas Trench, deepest place. Deeper than Mount Everest is tall. Okay, up there where I just went, we have the Aleutian Trench, that's in Alaska. And over here, this is the Cascade Mountains. And fill these all in. Did I get them all? Nope. Okay, and to name some of these, so as I said, we have over in South America are the Andes Mountains. And let's see, over here is India hitting into the Eurasian plate, and that's where Mount Everest is. And over here, it's hard to see, but this is where Japan is, right? And those are our main convergent boundaries. Then there's also, if we look at the bottom, a complex or uncertain plate boundary. So for those, it's a little unknown of what's going on. There are these dashed lines. Okay, the East African Rift, it is rifting, but it is very complex. It has those arrows showing that it's spreading apart. Okay, and you can just look at where those are. And the last bit, I just want to go to page 10. And we're going to look right here, and it's showing our convergent boundaries. So we put divergent, and we can put convergent over here, and it shows that there is a trench, so you don't have to memorize that. It's showing the direction of the convection that's occurring. It's saying the cascades, and where are the cascades? Well, if we go here, our cascades are right over here. Okay, those are our Cascade Mountains. So up in the Pacific Northwest of the United States. Okay, and that is all for our convergent boundaries.